Good morning, my dear friends. I hope you all are doing great. So let us start our class for today. Match the following and come up with the right option. So we have column A with us, column B with us. So you have some options here and here you have some options. You just have to match them up and you have to come up with the right answer. So my dear friends, let us start. Let's take on first of all phenylketonuria. First of all, if I write down here phenylketonuria, so it is a disorder, okay? This disorder, you can say, or disease, you can say, is detected in newborn babies. So my dear friends, this phenylketonuria disorder is detected in newborn babies. That's our first point. Second point is that it is caused due to deficiency of phenylalanine hydroxylase enzyme. Deficiency of phenylalanine hydroxylase enzyme. So due to deficiency of phenylalanine hydroxylase enzyme, this disease is caused. But what is the role of this phenylalanine hydroxylase? Let us understand. Phenylalanine hydroxylase can convert phenylalanine into tyrosine. So the role of phenylalanine hydroxylase enzyme is to convert phenylalanine to tyrosine amino acid. But when there is an absence of phenylalanine hydroxylase in newborn babies, then what happens? The phenylalanine will not be converted into tyrosine. So that means the phenylalanine will remain in the body. Okay? So have a look here. Due to deficiency of phenylalanine hydroxylase, the phenylalanine amino acid, this amino acid is converted by other enzymes into one more amino acid, we can say, or one more compound, we can say, that's called as phenylpyruvate. So it's converted into another compound. So this is not an amino acid here, it's another substance actually. In previous case, phenylalanine hydroxylase, if you look here, phenylalanine amino acid is converted into tyrosine. But I told you that in this disease, phenylketonuria, the phenylalanine hydroxylase is not present. It is deficiency is there. So I wrote here, due to deficiency of phenylalanine hydroxylase, your phenylalanine will not change into tyrosine. When it does not change into tyrosine, then what happens? Look here. Due to deficiency of phenylalanine hydroxylase, the phenylalanine, this one, phenylalanine, is converted by other enzymes. So other enzymes will convert it into phenylpyruvate. Phenylpyruvate. So my dear friends, so I can write down at the end of the day, okay, this particular, disease, this phenylketonuria, okay, this disorder or this phenylketonuria. So please understand that this PKU is nothing but phenylketonuria disorder can cause mental retardation, can cause mental retardation in newborn babies. So that development of the brain, the intellectuality, okay, the efficiency of the newborn babies will be lost actually. So this phenylketonuria can cause mental retardation. Okay. So my dear friends, in this disease, the enzyme which is deficient in the body is phenylalanine hydroxylase. So phenylalanine will not be converted into tyrosine. Phenylalanine will not be converted into tyrosine, correct? But phenylalanine is converted into phenylpyruvate, correct? So what is the way to prevent this particular thing? If newborn babies does have the deficiency of an enzyme called as phenylalanine hydroxylase enzyme deficiency is there, okay, then you should give that food to the babies which does not contain phenylalanine, because otherwise this phenylalanine will be converted into phenylpyruvate and that will cause the mental retardation. So my dear friends, the newborn babies should be given that diet which is not having phenyl, alanine in it. Okay. So I will write down here, can you folks it here? The diet which does not contain phenylalanine amino acid should be given to babies, because we know that phenylalanine hydroxylase enzyme is not present, okay. Due to the absence of that, the newborn babies cannot digest phenylalanine, okay. So what will happen to phenylalanine then? It will be converted into phenylpyruvate by other enzymes, okay, and that will cause the mental retardation. So please remember, a baby suffering from phenylketonuria should be given the diet which does not contain phenylalanine, because that baby will not be able to digest it. I hope you are understanding, or will not be able to convert it into tyrosine, or phenylalanine will be converted into phenylpyruvate by the other enzymes that will cause mental retardation. Please have a look. So our phenylketonuria will go to this option, Q. So first will be joined with the Q. I hope you have written, everybody has written this thing. So let me erase it and let's go to the second point now. So my dear friends, the second point is albinism. This albinism is because of tyrosinase enzyme. I will just tell you, because of the deficiency of this enzyme. Okay. Albinism. This disorder is because of the deficiency of an enzyme called as tyrosinase. So due to the deficiency of this enzyme called as tyrosinase, what will happen? Have a look. Due to deficiency of this enzyme tyrosinase, what will happen? Albinism will be actually framed in the body. What is that albinism? That the melanin pigment, okay, formation will be very less in the body, correct? Due to the formation of less amount of melanin pigment in the body, the color of skin and the hair will turn out to be white. So the skin and the hair color will become white due to the deficiency of which enzyme? Tyrosinase, and it will cause albinism. I hope you are understanding, my dear friends. Please have a look. So dear friends, As I told you, in albinism, the disorder is because of the deficiency of enzyme called as tyrosinase. When this tyrosinase is not in the body, then what will happen? Have a look. Less amount of melanin pigment is produced. Okay? So, the melanin pigment production will be very less. So I am telling you here, less amount of melanin pigment is produced. So when melanin pigment production is less, then what will happen? Please look here. Due to decrease in production of melanin pigment, skin and hair become white. So the skin and hair color will become white. So please remember that. So my dear friends, when the melanin pigment, okay, which is responsible for giving the color to skin and the hair, if the production of melanin is very, very less because of the deficiency of which which enzyme? Tyrosinase, then what will happen? The color of skin and hair will turn out to be white. So your hair and skin will become white in color because of this disease known as albinism. So it has to be matched up with the tyrosine. Then finally you have lactose intolerance. If we talk about lactose intolerance, what happens? Have a look. Lactose intolerance. The inability of a body to digest lactose. So the lactose sugar will not be digested properly by the body. Okay, why? Due to deficiency of enzyme lactase. So because of the less amount of lactase, okay, this lactose sugar will not be digested properly. You know that if you have a lactose in presence of lactase enzyme, it will undergo acid hydrolysis. It will give me glucose plus galactose. So I will be getting glucose plus galactose. So this reaction will not happen. That means your lactose should be converted into glucose and galactose. But this enzyme is very less. Okay? So when this is very less, then what will happen? This reaction will not take place properly. Means lactose will not break into glucose and galactose. Lactose will not break into glucose and galactose because of the deficiency of lactase. And this is known as lactose intolerance. Means your body is not able to digest the lactose. Is it clear? So my dear friends, if we look at now lactose intolerance, then I have to go here. Inability of a body to digest lactose because of the deficiency of what? Lactase enzyme, correct? Then hyperglycemia. Hyperglycemia is a diabetic condition. So what happens here in hyperglycemia? Increase in blood sugar level. Okay? So the sugar level in the body or in the blood becomes very high, above normal. So that is hyperglycemia condition and it's related to the diabetes. So I hope you have understood, my dear friends. So first option is phenylketonuria. It's related to phenylalanine hydroxylase, that's Q. So first one with Q. So first one with Q, that's correct. Second one with R. Second one with R, that's also correct. Third one, lactose intolerance. Third one with P. Third one with P, inability of the body to digest the lactose. Correct? Then the fourth one, hyperglycemia with S. So hyperglycemia with S. So my dear friends, the first option is the correct answer. Okay, I hope you have understood. Please make note of this. Dear friends, let's look at the question number 50 here. Which one among the following is Aldo Pentose? So aldose stands for basically here aldehyde, correct? Pent means 5 carbon atoms and ose means sugar. So that sugar which contains 5 carbon atoms and one of the carbon atom is aldehyde in it. Okay, so let's have a look. If you look at arabinose's formula, if you look, its formula is C5H10O5, correct? Xylulose is also the same formula, C5H10O5. If you look at mannose, you know that mannose, galactose and glucose, they have same formula, correct? So what was that? C6H12O6. And even sorbose has the same formula, C6H12O6. Now we have to tell that which one among the following is Aldo Pentose, correct? So which one among the following is Aldo Pentose? See here, this is pentose. This guy is our pentose because it contains 5 carbon atoms. This also contains 5 carbon atoms, so it's also pentose. This contains 6 carbon atoms, so it is hexose. This contains 6 carbon atoms, so it's also hexose. Now look here, my dear friends. Arabinose basically has 1 carbon atom as aldehyde. In arabinose, 1 carbon, the first carbon is basically aldehyde. So I will call it as Aldo Pentose. In case of xylulose, the second carbon is ketonic carbon. That means ketone is there. So I can call it as ketopentose. Mannose, we know it is similar to that of glucose and galactose. So first carbon will be aldehyde only. So it is aldohexose. Then sorbose is basically ketohexose. It has a ketone. Okay. So my dear friends, our first choice, arabinose, is basically the Aldo Pentose. Please remember this particular thing. So the answer is arabinose is a Aldo Pentose. Please remember it. My dear friends, let's discuss about now RS, system of nomenclature, also known as absolute configuration. So my dear friends, when in examination there comes a question that you need to find out the RS configuration in a particular amino acid or in a particular sugar molecule. So at that time, what you are going to do? Okay, let us understand first of all what is this RS system of nomenclature. Okay, so R basically here means rectus. Okay, and rectus basically means clockwise. Okay, and if we talk of S is basically sinister, and sinister means anti-clockwise. Let us suppose in your examination you have an amino acid with you. Okay, let us suppose this is an amino acid with me, with a carboxylic group, with CH3 group here, with hydrogen here, and with NH2 group here. Correct? They will tell you in examination, find out the configuration. Which configuration? Absolute configuration. And that will be your RS configuration in this amino acid. Let us suppose they will give it as alanine. So if you have an alanine amino acid, you have to find out the absolute configuration in alanine. Okay? And remember, absolute configuration is found, okay, around the chiral center. So you have to first of all decide which one is a chiral center in alanine molecule. So this carbon which is in the middle is basically a chiral carbon. So I will write down it as chiral carbon. So I have to find out the absolute configuration around this particular chiral carbon, my dear friends, this C. So I have to find out R or S configuration with respect to chiral carbon. So I will write down RS configuration is to be found with respect to chiral center. But now there is a term that how is it done? Let's understand that how it is done. Have a look. You know that this chiral carbon is surrounded by 4 different groups. This chiral carbon is surrounded by 4 different groups. So we will be giving the numbering to these groups, correct? From 1 to 4. Okay? So how we will give the number to these groups based on their decreasing atomic numbers. Okay? So have a look. Let us suppose this is the carbon with me, correct? And if I open up this group, it will be C double bond O and OH. Which atom is directly linked to the carbon, chiral carbon? This C is directly linked. Who is directly linked here? Hydrogen. And now in this NH2, if we look at this NH2, who is directly linked with the chiral carbon? Nitrogen. If we look here in CH3, who is directly linked to the central carbon? That is this carbon. So now, my dear friends, those atoms which are directly linked to the chiral carbon, are numbered from 1 to 4 based on their decreasing atomic numbers. So I will write down the atoms which are linked directly to chiral carbon are numbered from 1 to 4 based on their decreasing atomic numbers. Correct? So let's have a look, my dear friend. Let's take on these substances with me. First of all, which thing is directly linked to the chiral center? Carbon. And here also carbon. But who is linked here? Nitrogen and here hydrogen. So my dear friends, we will be numbering these groups, okay, from 1 to 4 based on their decreasing atomic numbers. Okay, so we have to write down first the highest atomic number, then finally the lowest atomic number. So decreasing order of atomic numbers. Correct? Have a look. Let's take these 4 groups. Okay, the 4 groups we have. Let's take the first one, hydrogen. Second group you can take on carboxylic acid, and third group you can take on NH2. Okay, and the fourth group you can take on CH3. So my dear friends, we have these 4 groups with us. Correct? If you look at these 4 groups, my dear friends, let's find out their atomic numbers. And you should know that the atoms which are linked directly to chiral carbon, okay, are numbered. That means these atoms will be numbered like hydrogen, carbon and nitrogen, not the entire group. So we have 4 groups. So let's talk about their atomic numbers. So these are the groups with us. What is the atomic number of hydrogen? 1. We know that hydrogen is directly linked to carbon, that is chiral carbon. So obviously the atomic number of hydrogen is 1. Correct? Then if you look at the second choice, here you have a carbon which is linked directly. Carbon is directly linked to the chiral carbon. Correct? So atomic number of carbon is 6. And if you look at nitrogen, this nitrogen is directly linked to the chiral carbon. So the atomic number of this nitrogen is 7. Now if you look here, this carbon is directly linked to chiral carbon. So carbon is directly linked to chiral carbon. So my dear friends, atomic number is 6. So my dear friends, if we talk of the purity, correct? So if you look here, based on atomic numbers, we have to write down them on decreasing atomic numbers. Correct? So which one has the highest? First of all, we have to take highest, then lowest. Highest is here nitrogen, that is 7. So nitrogen is the highest. So dear friends, if we go into the priority rule, okay, what is that all about? If you look here, you will find out that some element or some atom does have the highest atomic number. Who is that? The nitrogen with 7. So if you look at this, the atoms which are directly, linked to chiral carbon are numbered from 1 to 4. So 1 to 4 numbering should be given to those atoms, okay, based on their decreasing atomic numbers. So the highest atomic number should come first and the lowest atomic number should come last. Now if you compare these 4 atoms, hydrogen, carbon, nitrogen and carbon, you will find out that the highest atomic number is NH2 group, means nitrogen, atomic number 7, that is the highest. So highest will go from 1. So I can call it as 1. So in priority, okay, what we have to do is that I will take out this NH2 group. So NH2 group of the nitrogen of NH2 group has basically the highest atomic number. So it will be taken as number 1 group. So I can call it as 1. Correct? So after that, my dear friends, after NH2 group, who is the second? Who has the second highest atomic number after 7? It is 6 and 6, both are same. Okay, if you compare this 6 and 1, who is highest? 6 is highest. 6 and 1, who is highest? 6 is highest. That means these two, carboxylic group and methyl group, are having higher atomic number than hydrogen. Carbon's atomic number is 6, hydrogen's atomic number is 1. So highest is carbon only. So here also the highest is carbon only. That means the lowest atomic number is for hydrogen. Okay, so lowest atomic number is only for hydrogen. So the lowest will be represented by 4. Highest is represented by 1 and the lowest will be represented by 4, and that is nothing but it's your hydrogen, correct? So my dear friends, in between them we have now 2 and 3. But 2 and 3, which two groups will take the position of 2 and 3? Because our numbering should be from 1 to 4. And this 1 you should remember, it is known as the highest priority in terms of atomic number. Highest priority basically here means this group, this nitrogen has highest atomic number, means this NH2 group, okay? Now if you talk of the 4, hydrogen has basically the less atomic number. So this 4 is being considered as, let me write down here, 4 is taken as the lowest priority. So we got our highest priority and lowest. The highest was nitrogen. Nitrogen's atomic number was 7. So it has the highest atomic number, so priority is 1. Hydrogen's atomic number was 1. So its lowest priority, 4 is the lowest priority. Okay. Now between them we have 2 more choices. Correct? So that is 2 and 3. So look here now, my dear friends. If you look here, we have 6 here, here also 6. Carbon's atomic number is 6, carbon's atomic number is 6. So both are same. Carbon, carbon I will cancel. Now my dear friends, if 2 atoms will have same atomic number, then what to do? Then you have to decide on the basis of the other atoms which are in the same group. Let us see who is the other atom here. Oxygen. So let me decide now on the basis of oxygen here. And who is the other atom here? Hydrogen. Let me decide on the basis of hydrogen. I can write down this CH3 like this, like H, H and H. So let me decide here on the basis of hydrogen now. Because carbon's atomic number is 6, carbon's atomic number is 6. So I can't decide on the basis of carbon. So I will decide now on the basis of other atom. Who is the other atom? Oxygen. Who is the other atom here? Hydrogen. So for oxygen, if you look here and here, so for oxygen, atomic number is 8. And for basically the hydrogen, atomic number is 1. So this is for hydrogen. So now I am deciding between carboxylic group and methyl group on the basis of the next atom. Who is the next atom here? Oxygen. Who is the next atom here? Hydrogen. So who is highest? 8 is highest or 1 is highest? 8 is highest. So when 8 is highest, carboxylic group will get the second priority and your CH3 group will get the third purity. Okay? So between carboxylic group and methyl group, who has the high purity? Carboxylic group, then methyl. So my dear friends, NH2 has already come at first place, so don't change it. Second purity will be here carboxylic group. And the third purity will be now CH3 group. So these are our purities here. So my dear friends, this is from highest to lowest purities. So you are moving from 1 to 2, 2 to 3, 3 to 4. That means you are moving from the highest purity to the lowest purity. So my dear friends, now I can number these groups as 1, 2, 3, 4. Correct? So I can number these groups as 1, 2, 3, 4. Then I will decide whether this molecule will have the Lactose configuration or sinister configuration. Please make note of this. So guys, let's take that example here. H, COOH. Then we have here basically CH3, and here we have NH2. We have already decided the numbers from high purity to low purity. So this will get the number 1. Carboxylic group gets number 2. This guy will get 3, and this guy hydrogen will get 4. So these are basically our purities or numbering for these 4 groups which are around the chiral carbon in alanine amino acid. Now after giving the numbers from 1 to 4, okay, we have to find out now whether this alanine has Lactose configuration or it has a sinister configuration. We have to decide now. So my dear friends, we know that the fourth one is called as LP. LP means basically lowest purity. So this is lowest purity because its atomic number will be very less for hydrogen. And number 1 is called as the highest purity. So this is the highest purity group. So this is lowest purity group and this is highest purity group. Now in order to find out Lactose and sinister, you should decide one thing. You know what is that? Have a look. Okay. In order to find out R or S configuration, okay, we ought to move from 1 to 3. We ought to move from 1 to 3, okay. So in order to find out R or S configuration, we ought to move from 1 to 3, okay, around chiral carbon, okay. So my dear friends, let us see here. This is the chiral carbon. I told you that in order to find out R or S configuration, we ought to move from 1 to 3 around chiral carbon. So I have to move from 1 to 3. So I have to move from 1, this is 2 and this is 3. Have a look here. This is my 1, this is 2 and this is 3 here. So I am moving from 1, 2 to 3. Now you will be thinking that I am moving from 1, 4, 2, 3. First, think that the fourth one, you should also understand. Imagine that lowest purity group does not exist. So my dear friends, you have to imagine that this fourth group, which is lowest purity group, does not exist. So when you imagine, you close your eyes and imagine that this fourth group does not exist, then you move from 1 to 3. So you move from 1, 2, 3. So when you are moving from 1, 2, 3, you will get an arrow. That this arrow direction is like this. Have a look. The direction of an arrow is like this. Can you decide now what is the direction of an arrow? The arrow is basically in clockwise direction. So you are moving actually in clockwise direction, and you have to imagine that the lowest priority does not exist. So you are moving from 1 to 3 like this. So the clockwise rotation, and clockwise basically means rectus. So this should be R configuration. Which configuration? R. But before saying that this is R configuration, you have to understand one more factor here, one more rule here. That is, have a look. If lowest priority group is on vertical line. If your lowest priority group, who is your lowest priority group? Fourth group. And who is your fourth group here? Your fourth group is here hydrogen. If lowest priority group is on vertical line, then R rectus, R is taken as R. That means rectus will be taken as rectus only, and sinister is taken as sinister. So these are the tricks actually, you remember the trick? So please remember this trick. If the lowest priority group is on vertical line, if it is on vertical line, then R is taken as R and S is taken as S. Now second point, if lowest priority means fourth group, if lowest priority group is on horizontal line, if it is on horizontal line, then R is taken as S. What is the meaning of this R is taken as S? If you get R rectus configuration by moving from 1 to 3rd, then R will become S, and S is taken as R, is taken as R. I hope, my dear friends, you have understood. When your lowest priority group is on vertical line, okay, fourth priority is on vertical line like this, here and here. Then if you move from 1 to 3, when you move from group number 1 to group number 3, like 1 to 3, according to priority you are moving, then R rectus configuration, if you are getting, that is rectus only. If you are getting sinister configuration, that is sinister only. But if your lowest priority is on horizontal line, if your lowest priority is on horizontal line, then what happens? R will become S and S will become R. When your lowest priority is on horizontal line. So let us decide it once again. Have a look here. My dear friends, let me take it up. So please have a look. COOH, and this is NH2, this is H, and this is CH3. We know that this is the first priority. I can number it here also as a first priority. This guy is the second priority, this is third, and this guy is fourth. And you know this fourth priority, which line is this? This is a vertical line. So lowest priority is on vertical line. So lowest priority is on vertical line. So when lowest priority is on vertical line, look here, the lowest priority is on vertical line, R is taken as R and S is taken as S. It means that rectus will remain rectus and sinister will remain sinister. So imagine now fourth group does not exist. Imagine for time being. Then move from 1 to 3. So 1, 2, 3. So which kind of rotation you are getting here? Clockwise rotation. So I am getting this as clockwise rotation. And this clockwise rotation is basically known as, this is our chiral carbon, my dear friends, here. So this clockwise rotation is known as rectus. So it will have R configuration. So I will be getting here R configuration. I hope, my dear friends, this alanine amino acid which I got does have a R configuration. I hope everybody has understood among you. Please make note of this. So my dear friends, let's take the same alanine, but I will interchange the purities now. Have a look here. Hydrogen was on vertical line. Now I will take hydrogen on horizontal line. I have taken it. So I will take some group here. Let's suppose CH3 group I will take here. And I will take here, let's suppose NH2 group. And here I will take carboxylic group. Correct? So my dear friends, we know that this is the first purity. And this guy will be the second purity, we know that. And this CH3 is the third purity and this is fourth. And remember, this is the lowest purity. And lowest purity is basically on which line? If you look here, this line. What is that line? Horizontal is on horizontal line. So if you look here, can you focus here? If the lowest purity group is on horizontal line, then R is taken as S and S is taken as R. So my dear friends, if your lowest purity is on horizontal line, then R is taken as S and S is taken as R. So let us see here. We have to move. I told you that you have to forget that the fourth is there while moving from 1 to 3. So let us move from 1 to 3. So this is our 1, this is our 2 and this is our 3. So we are moving from 1 to 3 and you have to think, you have to imagine that fourth does not exist for time being. So you are moving, look here, you are moving from 1 to 3. 1, 2, 3. Imagine that fourth is not there because somebody may think I am moving from 1 to 4 and 3. No. Think that 4 is not there. Think for a while that 4 does not exist, okay? This is out of plan. You think in that way. So what happens actually? You are moving from 1 to 3, but if you see here, my dear friends, you are moving anti-clockwise. So rotation is anti-clockwise. So anti-clockwise basically means S. So you are getting here S. Correct? So you got the S configuration. Because this arrow means anti-clockwise. This is anti-clockwise arrow. So you got here S configuration. But I told you, when lowest purity is on horizontal line, if you get R, it will be taken as S. If you get S, S will be taken as R. What you got? You got S. And lowest purity is on horizontal line. So when you got S, it will be cancelled and S will be taken as R. S configuration is taken as, so R configuration. That means our answer is R configuration, not S. So these are the certain tricks you have to remember. No doubt, the arrow will tell you here that it is S configuration. Arrow will tell you that you are moving from 1 to 3 in anti-clockwise direction. Yes? So anti-clockwise is taken as clockwise then. So no doubt the rotation is anti-clockwise here. But your lowest purity is on horizontal line. Because of the presence of lowest purity on horizontal line, what happens? The R is taken as S and S is taken as R. Which configuration you got? S configuration. So I will cancel the S configuration. It will be taken as R configuration. If you get here R configuration, then I will change, I will cut it and I will change it into what? S configuration. So this molecule actual has R configuration. But through arrow you will be getting S configuration. The reason that lowest purity is on horizontal line, it will change this. I hope, my dear friends, you have understood. When your lowest purity is present on vertical line, then if you get clockwise rotation, it will be clockwise only. R will be R, S will be S. But if your lowest purity, fourth group, is on horizontal line, correct? Then what will happen? If you get R configuration, it will be taken as S. And if you get S configuration, it will be taken as R. With this, I would like to end today's session. Have a great time. Yo, yo.